Started. Trying to stick to the schedule today. See if that works. I have two visitors from INRIA. No?
Yeah, we are
somehow. So who gave this presentation also at the HPC user support workshop at Supercomputing in November. And because they were quite close and working with NICs, and since we have also Bart, who is going to explain how he combines NICs and EasyBuild, it made sense to me to invite them, and they were happy to pass by as well.
Yeah, all right, thank you for the introduction. So I'm Valentin and this is Bruno. So Bruno is really managing day-to-day the machines in Grenoble. So we will be talking about NICs to manage the software environment. And the next talk, I believe, is more on the managing system dependencies. We'll see. So this is a system with how many machines are there?
We've got about 6,000 cores.
6,000 cores. So it's a small-ish system, and we can be a bit experimental. So I'll describe quickly the problem that we face, and I'll go at quite a length about explaining the NICs technology, the language, and the package manager based on it. And finally, I'll talk about how NICs is used in our system. And to finish, there is a big table where we can have maybe a discussion to try to compare with EasyBuild and other approaches. So of course, if we want to do package management, we want to be able to maintain the of packages which depend on each other, and be able to reproduce the build somehow and move and have the packages move from machine to machine easily. In high performance computing, we have other needs, right? We want this kind of right management. Users should be able to install packages on their own so that they don't have to talk to an admin. We would like to have community-specific packages, which means that, for example, you have chemistry communities which have their own packages. There might be some licenses or some proprietary compilers. We would like some users to be able to write their own packages, because there are some power users in this user base, for rebuilds to be automated. And also we would like, if possible, to be able to run the software both on the cluster and on, for example, the laptop for the person to develop their code. And ideally for the packaging to be transparent between these two. Users usually want to access build options in an advanced manner, let's say. And it's ideal if it's OS independent, because we usually don't have, in some cases, we cannot change the operating system on the machine, for example. That is hard. So there's a few solutions in the, let's say, package-based space. So EasyBuild, of course, but also Spack. And Geeks HPC, which I believe there's a talk tomorrow about. And then the container-based solutions, which are mostly about reproducing an environment itself. Whereas the package-based solutions are more of how to build an environment reproducibly. Container, of course, offers many features such as isolation, and they decrease the amount of sharing between users that we can have. So we will focus on the left side, and we will not discuss much the container-based solutions here. So of course, if we try to compare the three main approaches that exist, EasyBuild, Spack, and this NICs or Greeks approach, the table is quite large, and this is quite a headache. We will come back at this big table at the end of the presentation, so let's not read now. We'll see later about this. First, I will present the NICs ecosystem. So NICs is first and foremost, it's an expression language, so it's a functional language. It's a project which is 50 years old. There is a package manager based on it. There is quite a large collection of packages for this. There is a build system that uses the package manager and the expression language. There is also a Linux distribution based on these packages, and finally also a deployment tool for these distributions. So you go from building packages to configuring a network of machines. You can replace tools such as Ansible or something like this. You can do configuration management. So the expression language, it's a functional entering complete language. So it's not just configuration files. It's also a programming language which you can build abstractions in the code with. It is typed, and it has a large standard library where you can do anything that relates to building packages, fetching sources, doing tests. Just to be sure, who is doing functional programming here? Done in the past or is familiar with? Okay, about half. Okay. So there will be some examples of packages in this presentation, or you can have some idea of what it is. So why did these guys start this approach for packaging? Of course, because packaging is extremely complex. If you go to specific programming language, you have all these specific language-specific package managers, and there are many frameworks. So you need somehow to be able to build an abstraction. When you write your packages, you need a powerful tool to grasp and to model all these situations. So you can build abstraction layers with such a language. Also, if you have access to a full programming language, you can do some reusability, factorization of the code, which is non-negligible. And, well, I think functional languages are more readable and maintainable because they force you to express more dependencies. We will see more about that when we have some examples. So based on this expression language, we have a package manager. So I'll try to describe quickly from above this thing. So you define package in Nix expressions. We will see some examples. So you just write some code. This is source-based. It builds packages which are independent of the system. So you could install Nix on your laptop right now and start to download some packages. This works on Apple machines. It works on Linux environments. You don't have to have Nix OS to have Nix packages. You can do atomic upgrades and rollbacks, meaning if your package don't compile or you change your environment, something doesn't work out, you can just always reverse with a simple command, dash rollback with your Nix environment. So this is a helpful thing. You can have several versions of the same package on the same system, no problem. You just install whatever you like, use whatever you like at any time. You can install packages as a user or as an administrator of the system. Building and runtime environments are completely isolated, which is something I think at the moment is not really done by other solutions in HPC. We'll see more about that. Builds are reproducible from source. They are not byte reproducible at the moment because byte reproducibility is quite a hard thing. I would say they are definitely reproducible than other solutions because of the previous point. Nix has binary caches, so you don't have to rebuild everything when you use them. Garbage collection in order to get rid of old dependencies on your system that you don't need. And finally, you can use it imperatively as a user using some command line tools. Let's say I want to install this package and so on. But you can also have some declarative configuration where you define user environments for, let's say, for chemistry users to directly use all their software and they don't have to do the work. So the main package collection is on GitHub at Nix pkgs, which is the main repository for everything Nix. There are quite a few packages. So these are not HPC-specific packages. These are generic packages. The way things are done is that everything is packaged down to the libc. So there is quite a bit. It's an old project, as you can see, 15 years. Quite big. So the ecosystem is quite large. So this is an example of, we cannot see very well because it's in blue. What can we do? Tu peux faire un truc de changer le contraste peut-être sur l'écran. Ok, too bad. C'est pas. Ouais. Right, so it's not a big deal if you cannot see the strings here. So this is a package actually. Ça arrive à. Ah, c'est pas mieux, laisse tomber, c'est pas grave. Non, mais mets-le en plein écran et puis on. Yeah. So. Ah, it will. Oui, en haut à droite, t'as le. Might be better, yeah, and we can. Wow, bad color choice. Okay. Okay. I'll describe what. It's GrowMax, yeah, 1.6. So this is a package for GrowMax, yes, 1.6. It's all you need to package this application and have it available on the system. So you can see at the top dependencies for this package. You need OpenMPI and so on. We use some utilities to fetch the source of the package here. We specify what are the build inputs, which builds an isolated environment for building. And somehow we give some flags for the compilation. So you cannot see it very well because it's in blue, but for example, there are some arguments to this derivation. At the top, there are two flags, single prec MPI enabled. And here in the character string, they are used, here there is an if statement. They are used to modify the build options, okay? So it looks like this. So it's a language without, it's a functional language, so, sorry.
You may want this.
Which?
Laser pointer. So
Great, thank you very much.
And the other thing is, if you can select it, then the background is better, then you can read it from the back, if you have a chance to do
I understand, but selecting actually made it worse when we tried, so, yeah, sorry. Thank you very much. Okay. Ouais. Okay, merci. Okay, so once we build, once we can build a package like this, it goes in something called a NIC store. So there is a unified location on the system for all packages to reside. /NIC store. Every package is identified with a hash of the source and the inputs of the build. So for example, this is a CDO package that we have in Grenoble, and if I change a flag in the compilation option when I install the package, it produces a new hash. So when we have some packages that are built, we can also install them in user profiles. And so users have profiles which are independent. They can have an unlimited amount of profiles, and these profiles can be rolled back around. If you install something you didn't like, they can always go back to a previous generation of their profile. So this is kind of a way to manage the, let's say, module aspect with NICs. Other tools that are available in the space are channels, which are ways to provide some binary caches to your users with selected sources of packages. For example, there is a NixPKG unstable, which is the latest package collection from the Nix people, but also we have in our system, we have the Simon channel, which is our local HPC software that people use. And when they would install a software, users will run this command, and they will say what is the source of the package, and what is the attribute that defines the exact package they want to use. And this hits the binary cache, and if the package is not in the binary cache, it will build from the sources and dependencies. When we make packages available in the binary cache, we can choose to build many versions with different values of attributes, so users don't have to rebuild every time they want a new build attribute. So here we have 4 versions in Simon, double MPI, and MPI version, which correspond to the previous flags you've seen in the derivation. Users might want something quite specific, modify the derivation using their configuration file, in which case it will completely rebuild the package. But if they ask for something usual, Nix will hit the binary cache and make it faster. So in our system, here is a graph of what we have. These are 2 machines we have. Okay, so they both have some head nodes, and in each head node we have this /nix folder that is on the disk, and it's mounted in NFS with all the compute nodes. Okay, these compute nodes have only read access to this NFS. And we have this separate server with binary cache of our software. When users would like to install a package or change their environment, they log to the head node. What they do is that they install the package on the head node before submitting their job and going into the environment. They first set up their profile, then they submit the job, go into the job, and load the profile. Okay, so more detail. Can we see? We can see. There is a daemon that runs on the head. Okay, so here there are two head nodes, and there is there's a socket that is used to make the daemon available on all the head nodes. When a user connects to the head, okay, and they want to build a specific package that they've developed. So let's say it's a power user. They're writing their code on their local machine. They wrote a package. They connect to the head node. They ask the Nix daemon to build a package for them. They run Nix build or nix-n-i to install the package in their environment. The Nix daemon will build the package and put it in the Nix store, which it has read access to, and modifies their environment. This is not the only source of packages. As previously said, the users can also directly use packages which are in the binary cache. They might also use some package which is defined in one of these 2 repositories, the channel or the Nix packages, which is not in the binary cache, in which case it will be built in this situation. And there might be some packages that users are not able to build because of, let's say, private compilers or something like this that they don't have access to, but we can still build a package for them. In which case, the administrator will have to go to the build machine and trigger a build themselves to make this package built, and then it will be available in the cache. But the users cannot build it because they don't have access to the compiler. Okay. In our situation, after 12 months, there are about 50 users who use Nix regularly. The store is about 100 gigabytes. So how many users are there on the machine total? I guess 500. So it's about 10% who chose. So it's opt-in. Other users use the module system. About 20K derivations, which means a number of different packages that were built at any point, including dependencies. And 1,200 generations. Generations are the number of user profiles that were generated. So here are some references, which we can put the slides online somewhere at some point. The main website, nixos.org, there's everything you will find. And we have some specific documentation for our use at this point. So thank you very much, but there is a discussion time. We should now discuss what are the difference with SPAC and EasyBuild. Because we are not EasyBuild users, so we are not very confident about everything in this table. So how much time do we have? We have still about 8 minutes, so we can. Yes.
So you don't compare it. So you're not concerned about compiling with any of the advanced extensions like AVX, AVX2, FMA?
Qu'est-ce que t'en penses?
Because the way you're compiling, you're not using any of the, like you're basically using your compute as if it was 10 years old. Because all of the processor extensions, none of those are used since like SSC 4.2 in any of the NICs stack because of portability. Like you wouldn't be able to run code.
I think for the moment, if you want to use the new AVX option, for example, you just have to edit the source of the package at your option, like in the GROMAX.
So you do that in GROMAX?
Yes, and rebuild the package.
So, but then if you do that, then now what about your portability? So do you provide, do you have a heterogeneous cluster?
Sure, the binaries are not portable, but they are in a unique hash.
Right, but one of the problems with NICs is that it hashes the recipe or the derivation. But if you're making compiler options that produce a different binary based on the architecture, the hash would be the same, but the binary wouldn't be able to be used on another machine, even though the hash said it would.
No, the hash would be different. It's not the same build, so.
There's no data, but the thing is, if you use MArch native to say what your build with the native compiler extent, the best version of the.
Compiler is provided by NICs and the functions.
Yeah.
The binary is different because the host is different, not because the.
No, I think that NICs has some mechanism.
Yeah, they don't build optimized binaries. That's
Exactly.
That's their mechanism.
So if you want that, you
So
specify
you're
it in the
throwing
next
away
derivation.
like 4 times to 8 times the flop performance.
Yes, you would change the derivation to tell use this compiler, and that's it. And of course, you cannot do it on your laptop. I mean, because you would need all these specific options and so on.
But then you're also the feature of NICs about it being portable. It would no.
No,
longer be
then you
portable.
cannot do portability.
And then you have that problem of the hash derivation. It's one of the you look whenever they come up against this in the main line, they would throw away that compiler option, saying, well, it doesn't produce a consistent binary across all platforms. That's a bug to them, where that's a feature in HPC.
Mm-hmm.
It's something you can fix because you have your own store, right?
Right.
So if you include the architecture of the system, if you make sure that's included in the hash that Nix does, then on a different system you install a different hash and you can fix it that way. But you have to customize all those packages.
And you have to rebuild.
And you have to rebuild,
Yes.
and you have to rebuild them in your own store as well. So something I showed the slide yesterday, and I can show you FFTW. The way Nix installs it is very generic, and on a Haswell system, on a Skylake system, it's even going to be worse. You're going to lose a factor 2 or 4 performance just because Nix builds it very generically. So you really want to rebuild everything in your own store. So that's very important.
Yeah.
It's just something you have to be aware of that.
Yes.
But yeah, with your setup, you can actually handle it because you have your own store, and that's the first thing people talk to. You can handle it. Yeah. Can you go back to the numbers you showed? You said 20K derivation, so that 20K different installations of software. So different
Derivations.
versions. No.
It includes all the dependencies, and as every package depends on other packages and so on. To the GDC, you have
As soon as you change something, the whole thing changes.
One installation may result in a large tree of dependencies.
So it's 20K different combinations of installations.
No, it's the number of here is the number of packages with the version.
Mhm.
Right. Okay. That's a lot, though.
Yes, that's a lot.
For only 50 users,
Yes.
20K is like
Yeah.
humongous.
Yeah, yeah.
Mhm.
I think on our system we have 3,000 modules installed. So
Mhm.
each module is one installation, but that's for 2,000 users. Of
Yeah.
course, the users don't install them. We
Yeah,
do.
but that's not a problem with it.
No, and I don't think it's a problem. It's just it's a lot.
Mm.
With only 50 users, it's a lot. So
Yeah.
you're going to need quite a bit of storage
And
to,
we,
to
have
catch
we,
them.
gigabyte,
have, we
yeah.
have to say that we didn't run
Mm.
the garbage collector before collecting.
Okay,
the
so it
folders.
includes stuff that's not used anymore. Yeah. Okay.
Yeah.
Yeah. Good stuff.
Mm. There is a point of comparison. Well, build reproducibility. Of course, Nix or Gwix kind of thing forces you to express these dependencies. So it's not
that
just
and the
imperative.
environment from the US is a big plus.
So it's a plus, and also maybe it's tiring if you have already your system set up with all the dependencies and you need to re-express everything in Nix. Yeah, for the user environment, of course, no more modules. Huh? No more modules. Everything is Nix shell. So there is this command that you can use to enter a specific environment defined in a file that provides you all these dependencies. It's
So what if users want to combine different bits of software together in different jobs? They would have different profiles and they switch between
Yes.
the profiles?
They
Yes.
have to switch.
yes.
They,
They will.
they may do something else. They may have several profiles.
They just pick a
by
name and
changing the path, they can use
yeah.
one.
You can actually use Nix shell, this utility, as a shebang in a script that executes your job, and the script you just load the
With a
environment
specific
first thing
profile,
before
yeah.
running.
Yeah. Did you get any complaints from users that say, what is this Nix thing, and just give me modules?
We are opt-in on the Nix, so
So
it's
they,
just users who are motivated and convinced that it can be useful.
and what's the long-term plan? You're going to force this on people?
Ah.
The plan is to do our best with Nix, and if it doesn't work, we fall back to using.
Because now you're doing two things, right? You're doing Nix and modules
Yeah,
is
but
just
we
manual installations? Or?
Actually, we haven't do new installations in the module environment, and when we have new users, new software.
You tell them to use.
Yes.
Mm.
We not only tell them to use Nix, we help them, and sometimes we even connect. We sudo as the user and configure their Nix environment, and we say it's okay for you. You can use it. We have power users that are creating packages, and we have very we have users that are not able to understand even what it is for now.
Yeah.
So
Yeah.
we kind of
And then you just prepare the environment for them and tell them. Yeah.
Quite a lot of the software we install with EasyBuild right now in our system is commercial tools of various kinds that require all kind of special sort of setup and massaging to get them to fit even a module system. Is there any hope for like installing MATLAB through a Nix container or something like this?
we have made two packages of binaries.
The two examples we have are the Intel compiler. We have packaged it into Nix, just using the binaries. So that's one of the kind of packages that users cannot build themselves. We have to build directly on the binary cache machine. And the other package is the Casa environment. Casa is a a software for space imaging, I think. And it's very hard to build. Even I think there's no easy build recipe for this software, and we directly use the binaries. So it's not proprietary, but it's I think the same kind of problem, and it works. The way it works is actually very simple. You just have to copy all the binaries and just change the run path into the binaries. There's a little tool in Nix, provided by Nix, which is called patch elf. And with this simple binary, you can patch all the binaries and the libraries, the dynamic libraries, to have a different run path, to use the dependencies into Nix. So we have two cases where it works.
Right. Any more questions?
Can you say something more about the separation between the build and the runtime?
What do you mean between them?
Yeah, because you were saying in one of your slides that you have a clear separation between the building of your software and the runtime. So it's just by using static dependencies, or?
Yes, all the dependencies are static, right? So when you build a software, you have hard link to the link store. It goes to a hash. So when you run a software, the environment, first of all, matters less because most dependencies are hard linked. And second, if you want to have an environment that is pure, which means that you want to flush all the environment variables and so on, you can use a shell, which gives you
I think that the isolation is not between the build and the runtime. It's an isolation from the host system.
Yes, that's what we meant, yes.
At build time and at runtime.
And you have a strong guarantee that basically the build and the runtime environment is the same.
Yes.
Yes. That nothing can leak in by accident. All right. Thank you very much. You'll be here throughout the day if people have
Yeah,
questions,
and
or-
tomorrow as well.
Yeah, and tomorrow as well. Okay, excellent. Thanks.
All right, thank you.
Send me your slides, PDF, and I'll upload them.
We will.